In this video, we are going to see about the chemical properties of alkanes. We know that alkanes, they contain C single bond C and C single bond H. And C single bond C and C single bond H bonds are very strong. So, these alkanes are less reactive. So, among all the hydrocarbons, that is alkanes, alkenes and alkynes taken, we can say that alkanes are the least reactive and they react with the attacking reagents under certain conditions. So, first we are going to discuss about the substitution reactions given by alkanes. So, the first chemical property that we are going to study is about the substitution reaction. So, first one is substitution reactions in alkane. Now, what do you understand by a substitution reaction? In substitution reaction, one or more hydrogen atom of alkanes can be replaced by halogen, nitro group, etc. And here under substitution reaction, we are going to learn about halogenation of alkane. So, under substitution reaction, we are going to study about the halogenation of alkane. Now, what do you mean by halogenation of alkane? Halogenation of alkane means the hydrogen atom in alkane can be replaced or substituted by a halogen. And usually this halogenation takes place in the presence of light or at high temperature. So, this is the condition for halogenation reaction to take place for alkane. That is, the reaction must be carried out in the presence of light or at high temperature. Now, let's see what is the order of reactivity of halogens, or what is the order of reactivity of alkanes towards halogenation, or let's see which halogen will react faster with an alkane. And the order is fluorine greater than chlorine, greater than bromine, greater than iodine. So, this is the order of rate of reaction of alkanes with halogen. So, if it's a fluorination, that is a vigorous reaction, and it is very difficult to control this fluorination reaction. Now, after fluorination comes chlorination. So, let's see example for the chlorination of alkane. On here we are going to see about the chlorination of methane. So, fluorination reaction is very vigorous. Now, chlorination. Chlorination of methane. Now, methane means the formula is CH4. Now, in methane we have 4 hydrogen atom and all 4 hydrogen atom can be substituted by the halogen. So, here it is chlorination, which means methane plus chlorine, and the reaction halogenation takes place in the presence of light or high temperature. So, here in the presence of light, so I am going to write H nu. Now, first we can see one hydrogen from methane is replaced by chlorine. So, the product will be CH3Cl plus HCl. We have taken one chlorine from Cl2, which substitutes one hydrogen from methane. So, that hydrogen and the other chlorine from Cl2 will combine to form HCl. Now, I told all 4 hydrogen atom can be substituted by halogen, but it does not take place in a single step. So, this takes place in several steps, and finally we get a product where all the hydrogen atoms are replaced. So, the next equation will be CH3Cl plus chlorine in presence of light. Now, again from CH3Cl, one hydrogen will be replaced by chlorine. So, it becomes CH2Cl2 plus HCl. Now, the next equation from CH2Cl2, one hydrogen gets replaced by chlorine. So the product will be CHCl3 plus HCl. Now the last reaction will be CHCl3 plus chlorine. In presence of light, we get CCl4 plus HCl. So you can see we get 4 different products in the chlorination of methane, and let's name the 4 products. The 4 products are, the first product is CH3Cl. The name of this compound is chloromethane. Now next is CH2Cl2, that is dichloromethane. Now CHCl3, this is trichloromethane, or there is a common name for this, that is chloroform. So the formula of chloroform is CHCl3. Now the last product in which all 4 hydrogen atom gets replaced by chlorine is carbon tetrachloride. That is a common name, or the IUPAC name is tetrachloromethane, or the common name is carbon tetrachloride, and we know that carbon tetrachloride is a very good solvent. So this is the example for the chlorination of methane. Now next, the bromination reaction of alkane. We know bromine reacts with alkanes but less readily. So first fluorine will react vigorously, chlorine also will react, bromine will react with alkane but less readily. And let's see the example for the bromination reaction of alkane. Bromination of alkane. Let's write one example. CH3CH3, that is ethane, plus bromine in presence of light, H nu. Now here CH3CH3, we get different products, but I am writing only the first equation where only one hydrogen is replaced by bromine. Now out of the CH3CH3, any one hydrogen attached to carbon can be substituted by bromine. So the product will be CH3CH2Br plus HBr. Now we can write many products by substituting all the hydrogen, but I am not going to show all the products. So this is one of the product of bromination of ethane, that is CH3CH2Br. Now next is iodination of alkane. So next we have iodination of alkane. Now iodination of alkane, let's write the equation, example with methane plus iodine. Now this reaction is a reversible reaction. Now let's write the product first. The product is CH3I plus HI. Now CH3I is iodomethane, or the common name is methyl iodide, and HI is hydrogen iodide. Now why is this iodination of alkane a reversible reaction? That's a question. Now the answer is, it is because this hydrogen iodide formed, this is a byproduct, so this hydrogen iodide formed is a good reducing agent, and it reduces iodomethane back to iodine. We know that reducing agent helps in reduction. So HI is a reducing agent and it reduces iodomethane formed back to iodine. So we will not get the expected product, iodomethane. So direct iodination cannot be done for alkanes. What is the reason for that? Why direct iodination cannot be done for alkanes? Because the byproduct hydrogen iodide formed is a reducing agent and it reduces iodomethane formed back to iodine. Now, how can we do this iodination reaction? We have to carry out this reaction in presence of an oxidizing agent like nitric acid or iodic acid, HiO3. The name of this acid is iodic acid. So what will happen, this HNO3 or iodic acid, they are good oxidizing agents. So what happens when we do this reaction in presence of iodic acid or nitric acid? This oxidizing agents will oxidize HI, hydrogen iodide formed, back to iodine. Okay, we know that HI acts as a reducing agent. So reducing agent wants to get oxidized. So if this reaction is carried out in presence of an oxidizing agent like HNO3, this HNO3 will oxidize hydrogen iodide formed back to iodine, which means we are getting our product, that is CH3I. So I will write the equation where with iodic acid, how it oxidizes hydrogen iodide. If you carry out this reaction in presence of iodic acid, HiO3 will combine with HI and we get iodine. HI will get oxidized to I2 plus H2O, and when you balance the equation, it is 3 and 5 HI. So in the presence of oxidizing agent, this hydrogen iodide formed will get oxidized to iodine. So we can carry out the iodination of alkane in presence of oxidizing agents. So this is the substitution reaction of alkanes. Now we have a mechanism to study, that is the mechanism for the halogenation of alkane. We are going to study the mechanism for the chlorination of methane, and the mechanism I told, that's a common question that is asked in the question paper. So let's study the mechanism, and that mechanism is called free radical mechanism. Free radical mechanism for the halogenation of alkane. So the question asked will be, explain the free radical mechanism for the halogenation of alkane. So we are going to study this mechanism taking chlorination of methane. Okay, now we already discussed the products of chlorination of methane. We got 4 different products. Now any free radical mechanism, when you hear the word free radical mechanism, it means there is a free radical formed, and we know how a free radical is formed. It is formed by the homolytic cleavage of the covalent bond. Homolytic cleavage means in homolytic cleavage the bonded electron, one electron will be taken by each atom, and it's represented by a half-headed arrow, and we get free radical as the product. Free radicals are neutral species with an odd electron. So here we are going to discuss the free radical mechanism for the halogenation of alkene. And any free radical mechanism takes place in 3 steps. The first step is chain initiation step. Second is chain propagation. Third is chain termination. So we are going to write the mechanism for the formation of the substituted product, that is the halogenation of alkane. So step 1, I told you, takes place in 3 steps. So step 1 is chain initiation. Now what happens in chain initiation step? Chain initiation step, the chlorine molecule undergoes homolytic fission to form 2 chlorine free radical. So the first step is the homolysis of chlorine molecule. This is chlorine molecule. Homolytic fission is indicated by half-headed arrow, and it takes place in the presence of light, homolysis. Now on homolytic fission we get free radicals, and they are the 2 chlorine free radicals. Now step 2. Step 2 is chain propagation step. Now we have chlorine free radicals with us. Now what will this chlorine free radical do? It will break the CH bond of methane. one CH bond of methane will be attacked by the chlorine free radical and we get methyl free radical and HCl. So, in chain propagation step we have several reactions coming up. So, the first step in the chain propagation step is attack of one chlorine free radical on methane molecule. As a result, one CH bond will break. It undergoes homolytic cleavage and we get a methyl free radical and HCl. Now, let us write the equation. We have methane CH4 plus chlorine free radical. Now, in presence of chlorine free radical, any one of the CH bond will undergo homolytic cleavage. Okay, and what we get, this takes place in the presence of light, we get CH3 free radical plus we have one hydrogen free radical coming out. This comes out as H free radical. This combines with chlorine free radical to form HCl. So, CH3 free radical, this is called methyl free radical. Now, we know that the first product that we get is CH3Cl. So, we have methyl free radical with us now. Now, what is the next step? This methyl radical will attack the second molecule of chlorine to form CH3Cl with liberation of another chlorine free radical formed by the homolysis of chlorine molecule. So, let us write that equation. All these takes place under chain propagation step, that is, what is the step? The methyl radical, CH3 radical will attack second molecule of chlorine, another chlorine molecule. So, that chlorine molecule will also undergo homolytic cleavage. As a result, we get two chlorine free radicals. Okay, this will give rise to chlorine free radical plus chlorine free radical. One chlorine free radical will combine with CH3 free radical and we get CH3Cl plus this chlorine will go as another chlorine free radical. So, we got our first product for the halogenation or chlorination of methane, that is chloromethane, or the common name is methyl chloride. Now, I am going to give this step as A and this step as B. Now, what happens is this propagation step A and B give the principal product, that is CH3Cl, but we know many other products we get. All these products are obtained in the propagation step. So, this chlorine radical and CH3Cl that we got now, they will repeat the steps A and B and they set up a chain of reactions. As a result, we get the other products. So, this is our first product in the chlorination of methane. Now, we know the next product is CH2Cl2, that is by the replacement of one hydrogen of CH3Cl with chlorine. Now, let us write, I will show you how we get that CH2Cl2. Then we have CHCl3, CCl4. So, the same propagation steps are repeated to get the products, the other products also. So, I am going to show how to get CH2Cl2. That also happens in the propagation step. So, let us see that. We have CH3Cl. I am going to write the complete structure. CH3Cl plus chlorine free radical in presence of H nu. Now, here in presence of this chlorine free radical, any one of the CH bond will undergo homolytic cleavage. So, what will happen? We get CH2Cl free radical, CH2Cl free radical plus we have from this hydrogen going as H free radical, it combines with Cl free radical to form HCl. Now, the next is CH2Cl free radical, CH2Cl free radical will combine with another chlorine molecule which undergoes homolytic cleavage and what happens? One chlorine free radical will combine with CH2Cl and form CH2Cl2 plus another chlorine free radical is generated. Okay, so thus we got our second product, that is CH2Cl2. Same way we can have the other two products also by repeating these steps, that is A and B again. Okay, so this is our chain propagation step. Now next we have the last step, that is step 3. Step 3 is chain termination. Chain termination. Now from the name, chain termination means the reaction stops due to the consumption of reactants or due to the following side reaction. So the last step we have all the products we got, all required 4 products are obtained in chain propagation step. Now in the chain propagation step there will be many free radicals generated, and in the termination step these free radicals will combine among themselves, and finally we get many other byproducts also. So let's write the possible reactions in chain termination step. Their possible reactions are: chlorine free radical can combine with chlorine free radical to form chlorine molecule. Then CH3 free radical combining with CH3 free radical forming CH3CH3, ethane is obtained. Now one more product is obtained, that is CH3 free radical combined with chlorine free radical to form CH3Cl. So these the main free radicals that are generated in propagation step is chlorine free radical, methyl free radical. So they will combine among themselves and we get all these different products. Okay, and you can see one of our product is ethane. So you can say that in the chain termination step we have ethane as the product in the free radical mechanism of halogenation of alkane. So this is also something very important, that is there is a question, how do you account for the formation of ethane during the chlorination of methane? The ethane we got when 2 methyl free radicals combine in the chain termination step. So these are the different steps in the free radical mechanism, that is chain initiation, chain propagation and chain termination. So with this we complete the first chemical property of alkane, that is the substitution reaction, that is halogenation of alkanes, and under substitution we have only halogenation reaction to study. Thank you.